Guys, you know what I came up with? I came up with building a metal 3D printer. Or a 3D printer that can 3D print in metal as the filament instead of plastic. I think I can pull it off. What are your thoughts on that? Wouldn't that be cool? Most 3D printers that print in metal cost tens of millions of dollars. And I think I can make a desktop DIY at home version of it for under $30. So, do you guys get what I'm saying? I've seen people take a TIG welder, put it on a CNC machine, and then weld with it. It's automated welding. This is something very well established. Robotics has been used to weld stuff for ages. What I'm proposing is that you would weld in left and right paths the same way a 3D printer prints. You would just lay down a very fine little welding bead and just go left and right, and it would lay down layer by layer of metal using filler rod and a TIG torch instead of using plastic, and it would 3D print. Layer by layer you could build it up and you'd have a metal object. My understanding was that metal 3D printers have currently created a huge molten vat of molten metal and then fed that metal through a nozzle and printed that way. I don't even know how that's possible. Wouldn't that metal melt? No, you'd have to have a very high melting point extruder nozzle and tubing that just doesn't melt even though molten metal is actually flowing through it. That's crazy. And so these 3D printers are only used by aerospace and NASA and stuff, very high-end clients, and they're just not accessible, and they're multi-million dollar machines in huge factories. What I'm proposing is just a desktop 3D printer machine. It would just take little filler rod strips, and it would just feed that through and have a little TIG torch create a little spark and just melt that. And we're talking very fine sticks, very fine little spark, and just lay very small amounts of metal at a time. Just like a 3D printer barely outputs any plastic at all. It's just very thin layers. And it just goes back and forth, melting and laying down little bits of metal. And it wouldn't need to be anything fancy. In fact, you could retrofit a normal desktop DIY 3D printer, changing out the printer head from a normal extruder that extrudes molten plastic to instead have just a little mini TIG torch and a little mini filler rod, keeping all the same structure of the normal 3D printer machine. Do I know how to weld? Absolutely. I own a welder. I have experience welding. I'm very good at welding. And I've also done extensive research on the different types of welding. There's flux wire welding, which is the kind I bought. It's a $90 machine. There's MIG welding, which is feeding a solid wire that has no flux through, and that wire creates the spark as it contacts the metal surface, and gas is fed to shield the spark in order to prevent oxidation and impurities. Whereas flux wire welding, the flux inside the core of the wire that's being fed is what actually shields it. But that's very messy and sends out a lot of slag and sparks everywhere. But it's reliable in windy conditions, and you save money and hassle trying to get gas tanks all set up. And then you have TIG, which is the best. TIG just creates a spark using a tungsten rod that is non-consumable against your metal, and it just melts a little area of the metal surface, and you use filler rod in your other hand just to feed in metal, and that connects to your super hot spark and just instantly melts. and lays down a little bead, and you can control it very fine in order to weld even tiny, tiny electrical equipment and stuff. And that tiny, fine precision, very small amounts of metal being added type of welding with TIG, very controllable. If you combine robotics to control it properly, you can go back and forth really slow, adding small amounts of metal layer by layer in order to create metal 3D printing from home. DIY. This is game changing. To be able to 3D print in metal is just crazy. Like, that could create parts that you could use for building spaceships, robotics, all kinds of stuff in a very affordable way. Very strong parts that are precision engineered, ready to go. It saves you the work of having to 3D print in plastic and then use like lost PLA or lost ABS methods to convert that then to metal. But then for the metal, you have to melt down metal and then pour it into a mold and hope there's no air pockets, and the structure of it is usually weaker. I'm not sure if the structure of just 3D printed welds would be weak or not. I imagine they might be somewhat weak, but maybe not. If you have high quality filler rod and a really good penetration and everything and all the settings correct, I can see there being the possibility that it would be very strong. I've heard that sometimes welds are stronger than the metal being welded if it's done properly. So I think that this could be a great tool for people to have in their home workshops to be able to 3D print metal stuff. You could 3D print your own metal hydraulic cylinders and 3D print your own metal engines. I mean, that's where things could really take off from a maker's point of view, because 3D printing in these garbage plastic prints that, I mean, people are having a hard time even getting 3D prints to work for a quadcopter, and those don't exactly have to be Air Force level strength. And these quadcopters fall apart. Okay, so a metal 3D printer would be way better than plastic because it could be way stronger than plastic. Plastic 3D printers have limited usage. You pretty much just print in plastic just so that you can convert it to metal later, and then you're using casting methods, and usually the metal casting, it's just not strong enough for a lot of stuff. It's better to have like solid metal that wasn't just poured. Although it's strong enough for a car, but people were saying like you can't, for example, cast the metal parts that are going to be spinning fast in a rocket engine or something. But I'm thinking metal laid down as a welding bead very carefully could be, it's been shown like TIG welds can be stronger than the actual metal it's welding.
What's TIG weld?
TIG is tungsten inert gas welding, where basically a little metal nail called tungsten that doesn't, it's like a million degrees melting temperature, creates your spark. So you send power through that, and then you send power, the ground lead, into your metal surface, and you put it close and a spark is created because you're completing the circuit. But that doesn't melt. Only the metal you're touching melts because it has such a high melting temperature. So you stick it close and it creates a spark. So you can create a little puddle of molten metal that way. But with welding, you usually want to add metal to join two pieces of metal together or whatever. So for that, you have a filler rod. So in your right hand, you hold a little, like a pencil, more like the pencil lead, like a tiny little rod, and you just put in however much you want into the molten metal, and you feed it in. And that's the same thing as how 3D print works with plastic, except the plastic goes through an extruder and it melts as it exits. With this, you're taking the same little rod, except it's metal, and you're sticking it into the spark. So it's the same thing. Either way, a plastic rod gets melted and put in little layers and thin lines, layer by layer, to build up a model.
Yeah.
The same thing could be done with a metal rod. In little layers, layer by layer, it gets laid down, and it builds up a model.
But you need higher heat. Like, obviously it's going to be very, very
Yeah, it's just a little spark, but yeah, way higher heat, like 1200 degrees or whatever. And the other, for plastic, it's 300 degrees. But that doesn't matter as long as the plate,
Pretty cool, baby.
as long as the bottom plate doesn't start on fire or something.
Well,
Everything has to be designed for this.
how do they make metal pieces now?
Okay, right now, to make metal pieces, people a lot of times will sculpt it in clay, and then they'll create a mold, and then create or they'll put a mold, and then they'll pour molten wax into the mold, and then they'll take the wax and put it in sand, and then create a little tunnel to the wax, and then they'll pour in molten metal, and that replaces the wax. It's called lost wax method. And the wax boils out. You can also do that with PLA, lost PLA or lost ABS, where the plastic melts out from the molten metal pouring in. All of these methods, though, create fairly weak, in general, structurally non-integrity casts. Cast metal can be strong, but it's nothing compared to stamped metal or hydraulic pressed metal.
Stamped metal, hydraulic press.
Where the molecular integrity of the metal is improved by crushing it, by making it smaller, like tighter molecularly, organizing it by crushing it under pressure and heat. And that's way stronger.
Yeah.
Because otherwise, when you just pour metal in, it's getting access to a lot of air and it's cooling very rapidly. And so it gets little air bubbles. It's like porous. So it cracks in half easily. It's not strong because it's not like dense. It's very airy metal. And that's the issue. But it wouldn't be airy if you're putting filler rod into your weld. That's why welds hold even stronger than the normal metals. Because welds are just solid. There's no air pockets involved. So I think actually this would work. Now, there is 3D printing in metal available, but only for ridiculous prices, like for one part, $10,000. Like crazy, because they only work for jet engines and aerospace and space flights and stuff. And there's only, I don't know, like 50 3D printers of metal in the world.
Oh, so they do exist.
Yeah, but the way they do it is crazy. They take huge vats of molten metal in a huge factory. Like big bowls of molten metal. And they feed it through tubes. And then they feed it through a little nozzle. And they print like that. So they basically print like if you took a Elmer's glue bottle and you just started squeezing out the glue, except it's molten metal in the bottle. But that's $10 to $100 million per 3D printer. But what I'm proposing is a 3D printer that would cost under like $50 and do the same thing, except way better. No, I'm not exaggerating. I'm being serious, please. But under $50, part of that is that you're also going to be using salvaged parts from like TVs that you find by the side of the road. But if you didn't have anything salvaged at all, then maybe the price would go up to like $130 tops.
I want to see it.
So you think it's a good idea and I should do it? If I do it, others will follow. Others will start creating this. But I'll just create a prototype for myself and then I'll show like, hey, this can be done.
Okay, but what's the point of the prototype? Like, what are you doing with it? Like,
This is the point of a prototype.
Are you selling
For
it?
personal use. Not every invention I have can I create a factory, create a business around it, bring it to market, mass produce it. That's too much.
You can sell the idea.
No, because then you got to get a patent. I'm not going to be a patent troll. I'm going to give the idea to the world for free. But I'm going to benefit in that I made the first one. I get credit for being somebody that came up with something amazing.
Give you credit.
My YouTube video will show that I'm the first to ever do a 3D printer of this design that's so cheap. Using just welding as the technology. And you know what? I got the idea because people created CNC-based welders. But nobody thought, wait, if I can weld with CNC, why can't I weld layer by layer a 3D model? CNC just means a machine that goes left, down, up, right. Just like a printer or a 3D printer. It just means left, down, up, down, left, right. That's all that CNC means. A machine that does that. So I'm even saying that I could use my normal plastic 3D printer, change out the print head to instead be a TIG torch and a filler rod of metal, and using the same printer, 3D print metal.
Well, that'll be interesting to see.
So you think I should do it?
Yeah, I mean, why not try it? See what one of your Twitch people say.
So it's crazy that nobody's tried this before.
Yeah.
Do you agree that
Sure, have you Googled it?
if you could 3D print an aluminum frame for a quadcopter, everyone would do that, but people just try different plastics and end up with these weak solutions. Metal is superior to plastic. It's way stronger.
But why has the world turned to plastic? Because everything used to be metal based. Remember, that's what they said. Everything back in the day was better quality, but now everything's plastic. Like, why was that? Why did that transition happen? Obviously, there was business behind it, but why? How? Is it cheaper? Like, why?
Yeah, it's cheap. You can get plastic almost free.
So maybe that's why.
Yeah, and this still wouldn't be cheaper. It's great for makers. Even 3D printing metal won't have any impact on big industry. Big industry wants to stamp metal, create dies for metal, punch the metal. That's quicker to mold it. This thing could be made in 2 seconds. But if I wanted to make one off of that, I'm not going to create a huge 10,000 pound hydraulic press to punch those out every 2 seconds.
Yeah.
If I wanted to make one of those, I'd have to 3D print it from home.
Yeah, so then DIY.
So this is for custom prototypers and DIYers to make parts. And it would be superior by far to a plastic 3D printer, which only makes very weak parts. That only can go so far, only have so many applications. This guy, Renault Super Genius, he is trying to create a rocket, a homemade rocket, liquid fueled rocket. And he's trying to create parts using 3D printing. But people are all complaining because his plan was to 3D print the part and then create a mold for it and then use lost PLA method to pour molten metal in. But they said you'd be lucky if that fine precision part even had the metal flow to all the edges of it because it was too fine of a part. And so they said your only chance is to buy a big metal ingot and use subtractive method of cutting away metal, not adding metal. Another guy said, well, you can use metal sintering, which is where you take metal powder and you pour it into your mold and then you just bake it and it all becomes one piece of metal, which is very interesting. I didn't know that existed. But I think that this is even cooler, 3D printer that prints it in metal.
I know that when I saw your plastic pieces when 3D printing, it seemed kind of bubbly. Like, wouldn't you think that 3D printing would cause bubbling too? Like a lot of air pockets, I mean? Because you're putting pieces by pieces, so this piece and then this piece is cooling. So what if there'd probably be air pockets
No.
each line?
No, because each time you lay a line of weld, it melts the layer below again. So there's no temperature difference. Whereas just squeezing hot plastic onto cooler plastic,
So you just have
they
to
split
make
apart
sure
easily. They don't
that-
become bonded thermally.
So you have to make sure that the lines are close. Because what if your machine puts a line like this and it melts, but like very thin right there, and like not that.
Yeah, but it will for sure be able to do it close, and it can even overlap, like almost going into the layer below in order to be really close. And unlike with a 3D printer, where you can't like overlap too much, or else it's going to be like hitting the cooled layer and like knocking the model over, you could go really low and keep it very tight with a welder because it's going to fully turn to liquid the layer that's already been cooled. So it's going to keep turning everything to liquid. So it can just really go tight. The lines can be like right on each other, no gap at all. No space at all is required. Because it's so hot. And unlike plastic, it's going to become molecularly bonded because of the melting point.
Yeah, but what?
Whereas with 3D prints, it's not molecularly bonding the layers. It's only dropping a molten layer on top of a cooled layer. They're not even really stuck together by anything, except just kind of being warm and kind of like glued-ish. But they're not molecularly one structure. Whereas this welding setup would make it all one. Like it would literally be one piece of metal. It wouldn't have layers that are visible. Like that, even molecularly, they wouldn't be separate layers. It'd be one.
But what about like with 3D printing plastic? You 3D print the sides and you see it coming into being. But with metal, how are you going to do that? Because it'll probably start melting, right?
No, it wouldn't. It wouldn't melt to the extent that way lower down, many layers down, are melting. It just falls down. You could control the heat to just melt a very thin layer below and above, so that it will just add a little bit of height each time, not melting the whole structure down. It would add very thin layers. You're helping me create content. You're having good ideas, but I'm able to answer them. These are concerns other people would have too. So it's important that I'm crossing all the T's and dotting all the I's, that I can answer those types of questions. Anyone from chat have any concerns about my idea for metal 3D printer? Alright guys, I don't think anybody has any questions. It's kind of embarrassing that nobody else has come up with this and is selling this product. Why am I the first one to think of this? It's so obvious. TIG welding, you're literally feeding a stick the same size as the sticks that are feeding into a 3D printer. So why did nobody say, why don't I do the same thing and feed a metal stick in instead of plastic? And instead of having a little extruder head that just heats it, I have an actual TIG torch that creates a little spark that melts it. And you can lay down the layers the same way as you do with a 3D print. This is like so obvious to me. And 3D printing has been around for so long. Why has no one actually done this? It's scary. But I guess I had to be that guy. I'm the guy. That's not funny. I'm the guy. So they're calling me Cracker Man because I have crackers all over me. They said it's hard to take me seriously with crackers all over my shirt.
Yeah, baby, yeah.
Hey, just because I got cracker crumbs on me doesn't mean I'm not the guy.
Yeah, Einstein had some crazy hair. That didn't mean he wasn't.
Yeah, Einstein had some crazy hair and he was the guy.
Tesla had a crazy mustache and he was the guy.
What?
Tesla had a crazy mustache and he was the guy.
Who?
Tesla.
Tesla had a crazy mustache and he was the guy. Somebody has to be the guy, and sometimes they're going to have something crazy looking about them. Einstein was an idiot, but that doesn't change that he was the guy. He saw something nobody else put in the time to see before anybody else did it. That's the kind of the guy we're talking about. Somebody that is the first to come to some substantial thing that people should have seen before. Alright guys, so I officially added create metal 3D printer on my to-do list. Yeah, it's at the bottom of my to-do list, so I have to complete hundreds of other projects, such as build robot army, build drone army, etc. Probably year 2075. But that might change, we'll see, we'll see. Maybe I'll get things done ahead of schedule. Hey, at least me creating this YouTube video explaining in depth how this product would work will greenlight somebody else to make it. And I don't mind if they make it. If they make it, bring it to market, I'll be the first to buy one. I don't need to be the guy to make everything on Earth. But I'm the guy that is going to come up with everything. I've got to show other people my ideas. I'm not going to be greedy. I'm okay with not making all the money, making all the products, blah 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 of the whole world. But my ideas are valuable and I'm giving them away freely.